Okay, let's go to x of 5. And x of 5 is a bit long. So they're saying for each of the following languages, give examples of the strings that are contained in this language, and then give the grammar that generates each of these languages. We have 5 languages, and the first one, they're saying L1 is the language that contains strings, which strings are part of this ABC. Now this is the alphabet ABC, but this time means any possible string that we can ever form over this alphabet, any possible strings of any length. So when you see ABC star, it simply means strings of length 0 union strings of length 1, 2, 3 union blah 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 forever, that can be formed using these 3 boys here, A, B, and C. So they're saying that L1 is a language. Now what I told you yesterday was when I have an alphabet, let me call it sigma, then sigma star is a set that contains strings of any length using the symbols in this alphabet. And I told you that all languages we shall be seeing, all languages are going to be subsets of this puppy here, this one here. So L1 is the language which contains strings that are in this guy, but we are going to put a restriction. We're saying whereby the string W starts with A. You see, whereby the string starts with A. Now what is interesting here is that if I have a language of all those strings that start with A, what is the simplest string in that language? The simplest string in that language is A, because if a string starts with A, then a string that has only A is correct. Now what is interesting is one, you may have an alphabet. For example, my alphabet may be A and B, but I told you that this star or the alphabet closure simply means that it means this, it means that, and we said forever. But I remember saying that the only string that has length 0 in this alphabet is going to be epsilon. So we're going to say we have this puppy here, we're going to union it with the strings in this language, in this alphabet, that have length 1, and that is A and B. Now what is interesting here is one, now these are now strings, but here they're called symbols. They're symbols in the alphabet, but they're also strings in the in the language that is defined over that alphabet. So what is happening here is one, when I have a language that starts with A, then the simplest string in that language is going to be A itself. Now whenever you have a language which is infinite like this one, because there are many strings that start with A, when you are trying to find the grammar, for me to find the grammar, what I do is simple. I first do the automaton. After the automaton, I can deduce the grammar from the automaton. That is going to be very, very simple. But since this is an infinite language, the simplest string always in this language is going to be A. So what I do, I come and draw my automaton. I say my automaton as this state and as A. But since A is in the language, I say when you see A, you just come to this state here. Now this must be the initial state. I do that. But since A is in the language, this means that this capital A must be an accepting state. So I give it two circles. I hope this makes sense. So what is interesting is one, so this is the skeleton or the simplest case of our automaton. So what the language is having A, B, and C. The alphabet has A, B, and C, which means we can simply get either A, B, or a C. So when I'm here and I see a B or a C, I don't care about them. So what is happening here is one, when you see A, that is okay. After seeing an A, all other guys, if it is A, if it is B, if it is a C, you can accept them because the string has begun with A. I think I understand what I'm talking about. Now when I see a B or a C, I can have a state here, let me call it B. When I see a B or a C at the beginning of the string, then these strings must not be accepted, because the strings in this language must always begin with A. So when I come to this state, what I do is I trap everything that happens after. Because when we see a B or C and we come here, since whatever I get we are coming here, we can never reach the accepting state. So these strings that start with B or C will be rejected. So this is an automaton. You see? It has a starting state, it has a final state, and we have this state here which is a trapping state. It traps these strings because they're not accepted in the language. But for now, when you're using an automaton, to find the grammar, we don't care about the trapping states. So forget about this one here. So when I come here, I'm going to be like, okay, when I'm in S, I do this arrow. When I'm in S and I see A, I go to A. I see small a, I go to capital A. You see that? Now I come to A, I'm done with S. Don't care about the B and C's, no? When I'm in capital A and I see small a, I come back to capital A, you see? Or when I see small b, I come back to capital A. Or when I say small c, I come back to capital A. Now, since capital A is an accepting state, it must also produce epsilon. You get it? So I told you that a grammar has 4 tuples. It is a tuple which has 4 guys. We talked of a grammar having the set of terminals, the set of variables, the starting symbol, and the production rules. So in this case, our grammar, what is our x? Our x is the set of terminals which is the same as the alphabet, and it is A, B, and C. Our v, it is a set of variables, but variables are simply the states in the automaton. I told you that don't care about trapping states here. When we're using the automaton to find a grammar, we don't care about the trapping states, because B and C, all strings that begin with B and C are not in the language, so we don't care about them. The grammar must only generate valid strings. So our V here is S and A because our automaton has only 2 states, that is S and A. Now, what is our starting symbol S? It is simply S, and these are our production rules. So we are going to say that our grammar is A, B, and C. That is the X, comma. V is S and A. Then S is our starting symbol, and our production rules, we have S, that, the first one, and this one here. Oh, we have A, that is A, that is BA, and that is CA, or epsilon, and this is our grammar. You get it? This is our grammar. This is the grammar they wanted. You can go and cross-check it in the solutions they provided. It will make sense, I'm sure. Yeah.